Hello and welcome with another video. It's something again very interesting, and in my last lecture I was discussing with you the conformational analysis of ethane, and I explained you the different forms, that is the staggered and the eclipsed forms of ethane molecule, right? So I'm Professor Dr. Mchem from Dr.Mchem Institute of Chemistry, University of St. Jamshire, and I'm very much here again with the continuation again of that same topic. But yes, this is we are going to encounter a graph that is plotted between potential energy and a dihedral angle theta. Now you can see on the y-axis this is a potential energy graph, right? Potential energy, whereas from 0 these are the angles, that is the dihedral angle, 0, 60, then 120, then 180 degrees, and so on. So these are the dihedral angles, and you can see different forms, the eclipsed and the staggered, and then again the eclipsed and the staggered forms under these these angles. That is at 0 degrees you can see an eclipsed diagram. You have to compare them. Now you're going to compare the above figure and the diagrams along with them. That is at 60 degrees you can see the staggered conformation, which is also called a Gauss conformation, in which the angles is at 60 degrees between the hydrogen atoms or between the methyl groups. So angle is 60 degrees, whereas at 120 you can see an eclipsed conformation, and where the angle between the atoms is 120 degrees, whereas in the last one, that is 180 degrees theta, when the angle is 180 degrees over there, you can see the figure down, a staggered conformation, right? The staggered one, this is the staggered conformation again. It is also called anti, when the angle between the atoms is 180 degrees. This is called the staggered conformation, and the anti-conformation, right? The staggered forms, which is anti. So let's this was a slight idea of the graph today, which we are going to discuss along with the different, something very interesting and something very related to your conformational analysis of ethane. So what is torsional energy of ethane? Today we are going to discuss the torsional energy of ethane. What is torsion? First of all, Torsion. What is torsion? So it is simply a resistance. You can see an ethane molecule, right? This is an ethane molecule. So it is a resistance to twist. It will have a rotational barrier, right? Resistance to twist, right? That's it. So this is called a torsion, right? What is torsion? It is a resistance to twist or rotate, and is also called torsional strain. It's also called a torsional strain or eclipsing strain. That means when you have a compound that is being eclipsed will be suffering a torsional strain, right? And the one that are not eclipsing, that are in the other forms, that is the staggered forms, they won't be having the torsional strain, right? Their torsional strain would be very less, whereas compared to the ones that is the eclipsing ones, the eclipsing ones will have the greater torsional strain. It has to face the torsional strain. And why it is that? Because torsional strain is only due to the repulsive forces among the electron clouds. Now, which electron clouds? That are in the carbon-hydrogen bonds, that is the carbon and hydrogen bonds. These carbon-hydrogen bonds, the electron clouds around them. So they have to face when it is eclipsing. This is the eclipsed form, right? This is the eclipsed form. So when it is having an eclipsed form, so there's a torsional strain, and it is due to the repulsive forces among the electron clouds, right? In the carbon-hydrogen bonds of the nearby carbons, of the carbon-hydrogen bonds, right? Carbon-hydrogen bonds of the nearby carbons. So this was the reason why it has the torsional strain, the eclipsing molecule, right? So I was explaining you the torsional strain. It is simply the resistance to twist or rotate, right? And is also called torsional strain or eclipsing strain. Now you have two terms, torsional strain or eclipsing strain, E-C-L-I-P-S-I-N-G, eclipsing strain, right? And is referred to as an elevation in a potential energy of a molecule, right? The elevation in the potential energy of the molecule. You can see in the graph elevation and again a decline. Then again an elevation, then again a decline, right? So the increase in the potential energy, then again the decrease, then again the increase, and then again the decrease. So I will explain to you now what does all that mean. Simply, first of all, you should know what are these, terms which are new to you, right? The torsional strain, eclipsing strain, and it is referred to as an elevation in the potential energy of a molecule due to the repulsive forces between electrons, right? Why this is happening? It is all because of the repulsive forces between the electronic clouds. So torsional strain can be seen to as a barrier to rotation. Yes, it is a barrier to rotation. The torsional strain is a barrier to rotation, right? The molecule can't rotate it if it's facing a torsional strain, as the molecule is in the eclipsed form. The eclipsed forms, they are facing the maximum torsional strain, right? So let's discuss other things now. So now let's discuss the graphic representation of this barrier to rotation, and I let you know how it happens. So now here in this simply between the eclipsed, that is this one, eclipsed, and the staggered conformation. This is the staggered conformation where the angle between the hydrogen atoms, front carbon hydrogen atoms, is 60 degrees, whereas here the angle is 0, right, when it's eclipsing. So between this eclipse and the staggered conformation, the staggered is lowest in energy. It is lowest in energy. Why? Because due to the large separation between the electron clouds of the carbon hydrogen bonds, right? You can see here the potential, the energy over here is this much, whereas here it is again, it lowers down when the angle is 60 degrees, right? So now between these eclipsed and staggered conformations, the staggered is lowest as compared to the eclipsed due to the large separation between the electron clouds of the carbon hydrogen bonds. Now whereas the eclipsed conformation, that is this one, brings the carbon hydrogen carbon hydrogen electron clouds closer. It becomes very closer and is how much? 12.6 kilojoules, that is this much, 12.6 kilojoule per mole or 3.0 kilocalories per mole, greater in energy. It is greater in energy than the staggered conformation, that is this one, that is this one, the staggered conformation. It is 12.6 kilojoule per mole or 3.0 kilocalorie per mole greater in potential energy in the staggered conformation, right? So this was something very interesting. Now the figure conveys, this figure, it conveys the increase in the potential energy of ethane when rotation occurs. Now the molecule is constantly rotating here. You can see this, these are the rotations, right? The angle is constantly increasing, the theta. You can see theta, the dihedral angle. This is theta, right? So you can see here it is 0, 60, 120, 180 degrees, and then theta here. So it goes on. It is increasing. So you can see that when the ethane molecule, it rotates. What's happening? When the rotation occurs between carbon-carbon bonds, right? The potential energy of ethane, it increases, right? Between the graph is now between the potential energy, it is plotted between potential energy and the dihedral angle, theta. You can see the dihedral angle and the potential energy. Now the y-axis has the potential energy, this is the y-axis, has the potential energy, and x-axis is the theta, that is dihedral angle, increasing from 0 degrees to 180 degrees. Okay, so now 0 degrees, that means this one, 0 degrees. That is the eclipsed form. Now this is the eclipsed form when the angle is 0. This is, and what is this? This is, the 60 degree angle when the angle between the two hydrogen atoms is 60 degrees. It is called staggered conformation, whereas this is the eclipsed conformation when the So the graph is now between the potential energy and the dihedral angle theta, right? The y-axis has the potential energy and x-axis has the theta, that is the dihedral angle, right? I mean, starting from 0 degrees, that is here, to 60, 120, 180, and so on, right? The theta is increasing. So this is simply the rotation of the molecule. Now what is happening here? 0 degrees, that is eclipsed, right? The molecule is eclipsed. The ethane molecule is eclipsed here. You can see at 0 degrees, whereas at 60 degrees, it is in the staggered, that is in the, it is also called gauge, that is when the angle is 60 degrees. This is, the molecule is in the staggered form. The distance between the atoms is they are far apart from each other, so they are, the staggered of the conformation is, that is why it's called also more stable than the eclipsed conformation, as one of the methyl groups rotates 360 degrees as compared to the other one, as compared to the other. And what does that mean? That it rotates 360 as compared to the other, and the compound has to come across 3 stable staggered conformations. It will come across 3 stable staggered conformers, then through 3 unstable eclipsed forms. This is the reason why a staggered conformation of ethane is more stable as compared to the eclipsed one. Whereas the eclipsed is least stable. It has to face the torsional strain, right? The torsional strain, that is the rotational barrier due to the repulsive forces among the electron clouds in the carbon-hydrogen bonds of the, which I have just mentioned, that is between the carbon-hydrogen bonds. It will face the repulsive forces among these electron clouds in the carbon-hydrogen bonds of the nearby carbons. So this was one of the reasons. So now here, what is happening? That when ethane molecule, it rotates, right? Now here it is rotating, the angle is constantly changing. Here it's 0, then you can see when it's 0 the potential energy increases, then again it rotates, becomes theta, becomes 60, then it again goes, the potential energy increases when it has the angle 120 degrees over here, right? That is at an eclipse form again, and then again when it goes down at 180 degrees, so it has the anti-conformation, that is the staggered conformation. And so what is happening basically when ethane molecule, it rotates towards eclipsed conformation, the potential energy increases. This is what is happening when ethane molecule rotates towards the eclipsed conformation. When it rotates towards the eclipsed conformation, the potential and energy, it elevates, and resistance to rotation occur. What happens? The resistance to this rotation, it occurs. The molecule has the difficulty to rotate, right? So this resistance is termed as the energy. This resistance is simply termed as torsion or torsional strain. And how much energy is needed for that? 12.6 kilojoule per mole, or 3.0 kilocalorie per mole energy that is needed, and it is termed as the torsional energy. This is called the torsional energy which is needed. So what is conformational analysis basically? It is simply a study that explains energies of number of conformations or multiple conformations analysis, and it also helps to understand which reactions could take place and which conformations are going to be favored. So this was about simply the potential energy diagram and versus the dihedral angle theta. And here you can see the torsional energy. I've written also here, it is lowest in the staggered conformation, the torsional strain, because it's not facing the torsional strain, whereas the eclipsed molecule is constantly facing the torsional strain because of the closeness of due to the repulsive forces among the electron clouds in the carbon-hydrogen bonds and of the nearby carbons, right? And it is least stable, whereas this one is more stable. That is the staggered one. It is always more stable than the eclipsed conformer, as one of the methyl groups rotates 360 degrees as compared to the other, right? and the compound has to come across 3 stable staggered conformers through 3 unstable eclipsed forms, right? So this was a very interesting topic, and I thought that I must share with you, and I must explain it to you in a nice way. So I explain you what is a torsion and what is, its definition, and why it is called a resistance. It's simply a resistance to twist or rotate, and it's also called torsional strain or eclipsing strain, because when the molecule is in the eclipsed form, it is facing the torsional strain, whereas because of the closeness between the atoms, whereas when they are far apart from each other, as in the staggered form, and they have the angle, right, 60, so they don't face that torsional strain. So torsional strain can be a reason to a barrier to a rotation. This is now confirmed that the torsional strain is the reason or a barrier to a rotation. So, and you have also learned that between eclipsed and staggered conformation, the staggered is lowest in energy due to the large separation, and it is more stable, as when it is lowest in energy, it will be more stable than the eclipsed conformation, right? Because why this one? Because due to the large separation between the electron clouds of the carbon hydrogen bonds, whereas the eclipsed conformation, this one, it brings carbon hydrogen electron clouds closer. It becomes very closer, and that is almost 12. How much energy is needed? That is 12.6 kilojoule per mole, or 3.0 kilocalorie per mole, greater in energy than the staggered conformation. Eclipsed conformation is how much greater? 12.6 kilojoule per mole, or 3.0 kilocalorie per mole, greater in energy than the staggered conformation. Then I've also explained to you about this figure, this whole diagram. Now I hope you understand how the molecule behaves when when the rotation occurs between the carbon to carbon bonds and ethane, and when ethane molecule rotates towards eclipsed conformation, when this one, right, or when this one, what is happening? The potential energy elevates, right? It elevates. You can see it elevated, right? It elevated, and resistance to rotation occurred, right? It will have a difficulty in rotation. This resistance is termed as the torsion or torsional strain. If somebody asks you what is a torsional strain, you can simply answer it, and you can tell it that how much for ethane molecule, how much energy, 12.6 kilojoule per mole, or 3.0 kilocalorie per mole energy is needed and is termed as torsional energy. So now, what is conformational analysis? You can answer that question also. It's simply a study that conveys or explains energies of number of conformations or multiple conformational analysis. It also helps to understand which reactions could take place and which conformations are favored. I hope you find this video very interesting, and you will definitely like it, and you will understand it, and you will compare it with your molecule, that what is the eclipsing form and what is the staggered form. This is I can show you here if I have few more minutes. This is simply an eclipsing form. This is the eclipsing form, and this is simply the staggered form. This is when the molecule is in the staggered form. This is staggered, right? The distance between the molecules, you can see right here at the 60 degrees, right? And this is again 120 degrees. This is 120 degrees when the molecule is having 120 degrees, and this is when it is having 180 degrees. The whole 180 degrees angle, that is this and this. So this is called an anti-conformation, right? When the angle between this and this is 180 degrees. It is also called staggered and anti-conformation when the angle is 180. When the angle is 120, it is called eclipse conformation, right? And when the angle is 60, it's called gauge conformation. And so this was something very interesting, and I hope you like this ethane molecule and how it rotates, and when it rotates in having on different angles, what type of forms you are going to get. So I hope you will compare it with your molecular model, or draw it on the paper, and then practice it as much as you can, because this is the only way you can learn. See you. Thank you very much. Bye-bye.